Hi there. Yeah, thank you very much, Yasmina. Thanks for the introduction. Just before we continue, just wanted to quickly make sure that you went over that agenda slide just so that you saw all the different things we've got coming up today. A real variety of stuff there. Really looking forward to seeing some of it. So you had a very quick introduction there. I'm Peter Cooper. I'm one of the conference chairs of the Fluent conference. Have been so 2012, 2013, and now next year as well. But we also do these online events as well, which are always great fun and allow us to sort of get an extra bit of knowledge out there. So just in case you aren't familiar with what Fluent is, it's essentially a conference that was initially created as a bit of a kind of a JavaScript crossed with web technologies. But I guess we kind of started to focus a little bit more on the web platform, and I think Simon might say a little bit more about that. But yeah, things are carrying on very well, and we're very glad to have you all here, and of course our speakers, who hopefully will entertain and delight. So I shall now pass over to my fellow co-chair, Simon St. Laurent, the chap you see on the right.
So yes, we're definitely expanding the show toward a more complete web platform conversation. It's pretty clear that the web platform works best as a whole set of pieces that are assembled together. And we hope to see you in San Francisco March 11th to 13th if you can make it. I'm co-chairing Fluent. I'm also co-chair of the O'Reilly Open Source Conference, so I'm hoping that we'll see some good crossover between these two kinds of events. And I think Peter can introduce our first speaker.
Yeah, without further ado, I need to introduce Mark Bates, a great guy. Got to spend some time with him last year because he spoke with us in 2013. Did a very highly rated CoffeeScript talk. But he's not covering that this time. He's basically doing something about all the different larger frameworks that you might use in JavaScript, which obviously includes Angular, Ember, and Backbone. Although I guess the guy that does Knockout might be slightly offended not being on this list. But it's an interesting comparison, interesting shootout, and I think Mark is the perfect person to give it, which is why we invited him on. So yeah, without further ado, thank you, Mark, and we look forward to your talk.
All right, thanks, Peter. Thanks, Simon. There we go. I think I got the first slide up. So if I do this right. Yeah, so I'm Mark Bates, and like I said, we're going to talk about Angular and Ember and Backbone. And funnily enough, the original title of this talk was Knockout.js, but I thought that was probably not the most appropriate title considering the framework Knockout.js. So the first thing I really want to talk about is philosophies when we talk about these three different frameworks, and these are three of the largest, and I say largest, I mean most popular frameworks, although one of them is definitely the largest in terms of size, and we'll cover that in a minute. Largest kind of frameworks, most popular frameworks out there. But each one has its own very different set of philosophies. When we talk about Backbone, Backbone likes to kind of pitch itself as this minimal set of data structures and primitives used to build JavaScript web applications. But really, I kind of look at it as kind of do what you want, we won't tell anybody kind of a philosophy. And we'll see that as we kind of go. It's very, very lightweight and really kind of leaves it up to you to figure out what it is you want to do with it. Ember likes to pitch itself as a framework for creating ambitious web applications. Whether that tagline is ambitious or not, I'll leave up to you. What I kind of really see Ember's philosophy as being is convention over configuration. And that's kind of a theme you'll see throughout this talk when it comes to Ember, and certainly everything they do. They've kind of taken this Ruby on Rails philosophy of if you do things and put things, if you name things the right way and put them in the right places, Ember will kind of do all this magic for you. Angular likes to pitch itself as a tool set for building frameworks for your application. I kind of disagree with that. I actually think it's a framework unto itself, and a nice one at that. To me, its real philosophy, though, under the covers, is really just plain old JavaScript. That's kind of what it's trying to get to. It's trying to make plain old JavaScript, to give you tools that you can use with plain old JavaScript to build these web applications. And we'll see that as we kind of talk through. So when I told people I was giving this talk, one of the first things they say to me is, you're kind of comparing apples and oranges and bananas because they are three very different types of frameworks. But personally, I actually kind of see them more as comparing a red apple to a green apple to a moldy orange. And I think you'll kind of pick out the moldy orange as we go. It's one of these is definitely a moldy orange in my opinion. Although I find that when I talk to people about this, they end up coming up with their own moldy orange and their own shiny red apple. So I'm curious to see in the group chat later what you guys think is the moldy oranges and which ones you think are the red apples. Okay, so let's jump right in here with this. First thing I want to talk about is weight, and when I talk about weight, I mean the actual physical size of the files themselves of these libraries. That is important considering how much mobile development is being done these days using these sorts of frameworks and libraries. When I'm talking about these sizes, what I'm talking about is what each of these library maintainers declares to be their production version, which is usually minified, and any required dependencies. I'm not talking about gzipped files. Those obviously can be a lot smaller, but different compression can give you different sizes, so I just kind of went with the standard uncompressed JavaScript that has been minified and is deemed production by the library maintainers. So let's look at a chart here, and unfortunately I converted this over to PowerPoint. The total numbers didn't show up on the bottom, but we can do some basic math. So looking at just kind of the core library, the base here, what is needed to just kind of even get started. Angular comes in with a 99K base, which is not too bad. It's up 10K in its latest release than the previous release. Ember comes in at a whopping 235K just for its core library, which seems very heavy to me. I mean, that's a quarter of a meg of JavaScript, and you haven't written a line yet. And then then Backbone comes in at 6.4K. And just looking at just that kind of baseline right there, 99K versus 235K versus 6.4K, tells you a lot about what each of these frameworks is trying to solve, what problems they deem are worthy of solving, and what they're trying to do. Backbone's trying to do very, very little for you, and Ember's trying to do a whole lot for you. So moving on, if we look at templating languages, Angular has a templating language built in, so there's no additional cost there. Ember doesn't require you to use handlebars. However, if you don't use handlebars, you're not going to get the kind of great data binding stuff that Ember really prides itself on. So to me, handlebars is a requirement to Ember, and that's 73K. And then finally, Backbone doesn't require you to use any sort of templating language, so you can use whatever you want, so I'm not going to penalize it there. For data adapters, the ability to talk to APIs and remote data sources, again, Angular has one built in. Ember uses Ember Data, which is 210K the last time I checked, which is a few weeks ago. But they are doing a lot of work on it, so that number may fluctuate. I don't think it's going to fluctuate wildly, though. And Backbone requires jQuery to do its data, for its data adapter, and that's 32K. So for support libraries, stuff that are required by the core themselves, Angular doesn't need any. You can use jQuery if you want, but it's kind of this jQuery-like thing built into it. Ember does require jQuery. Backbone requires jQuery. It also requires JSON2 and _JS. So when you look at those and tally those all up, Angular stays at its 99K. Backbone goes from 6.4K up to 60.3K. So it jumps, 10 times, almost 10 times its size once you add its dependencies in there. And it starts getting kind of in line with Angular. And as you go along, you'll see the difference between what Angular will do and what Backbone can do. It's quite remarkable what Angular is doing with that extra 30K. And then Ember comes in at 550K, which is, just it's insanely large at half a meg. Now, when you compress these, when you do, when we gzip them, they will get significantly smaller. But half a meg of JavaScript without writing a line of code is certainly something to consider when you're choosing one of these frameworks. And let's see here. So move on here, and let's talk about Mindshare a little bit. And this is important when you're choosing a framework, when you're choosing any sort of library or language or framework, you want to make sure there's a community around it. You want to be able to, make sure there's great plugins, great support, great, places you can go and get questions and answered and talk to other like-minded people. So Mindshare should really play into your, what you do when you pick a library or any tool. So if we look at Google, and this chart is a little small, what this is a chart of Google search results over the past year, I believe, for these keywords, for AngularJS, Ember.js, and Backbone.js. And the blue line is Angular, interest in Angular over the past year. The yellow is Backbone, and the orange is Ember. So you can see in terms of just Google Mindshare, now I should note that Angular is a Google project, but I don't think that they would go and kind of influence this sort of a chart in that way just because it's one of their own projects. Angular by far has the largest Mindshare in terms of Google search results and interest on Google, with Ember having the lowest and Backbone having the second kind of highest one there. So that is really important to kind of keep in mind when you're evaluating these. These GitHub numbers here are also a little bit small. These, at least on my screen, it's a little bit small, might be bigger on yours. So again, Angular has the largest screen share, Mindshare on GitHub. If we look at those numbers there, I can't see them, they're too small, unfortunately, on my screen. So you just have to take my word for it that they're bigger. There we go. The amount of stars Angular has is over 17,000. This was about 2 weeks ago. Ember's stars are just over 8,000, and Backbone's sitting at a respectable 16,000 stars. So we're kind of seeing a similar mapping in terms of what we just saw with the Google one as well, or the Google search results. Angular on top, Ember at the bottom, Backbone kind of in the middle there. In terms of watchers, Angular has twice the number of watchers as Ember, and Backbone, again, sitting somewhere in the middle. So that's the way it kind of plays out. Twitter has very similar numbers too, although I haven't posted them here. And again, that Mindshare is important when you're picking and evaluating these libraries. Okay, so we're all programmers here, I assume. Let's talk a little bit about code. Let's actually look at some code. That's what we're going to talk mostly about here. I want to start by looking at basic models. And what I mean by basic models, these are models that don't connect to a remote API. They're just kind of a basic kind of way to group data into a data structure. And we just kind of look at each one of these data structures. And one thing to note about all the code here, we're going to use, this is actually real code extracted from real applications that I built. I built the same application 3 times and did a whole web series on metacast.tv about it, so you can go and look at that later and watch the same app being built 3 different ways. So if you look at the first set of code here, this is the Backbone code for creating a beer object and a collection object to hold beers. Backbone has models, which are just, like I said, a single instance of a data structure, and then collections, which are kind of glorified arrays around those data structures. And yes, this is in CoffeeScript. As Peter said, I'm a CoffeeScript guy. I wrote a book on CoffeeScript, so I'm kind of obligated to use CoffeeScript everywhere I go here. But CoffeeScript is awesome, and you should all go and check it out if you haven't already. So this is the Backbone code to create a beer model, like I said, in a beers collection. Ember takes this kind of data mapper approach to building models, and you notice here that I'm extending a DS model, and everything in the Ember world is extended. You don't create kind of plain JavaScript objects anywhere in Ember. Everything is extended. That's part of its kind of convention, configuration philosophy. If you extend these things, you're going to get a lot of value out of it. But you see here, I also need to map each of my properties and the types of properties I get with Ember, which can be quite useful down the road when you're doing different things. And, it's great kind of documentation there as well. For Angular, this is how we create a beer model on Angular. It's very simple. Just create a simple JavaScript object. So that, again, points to that Angular philosophy of plain old JavaScript. You'll see this later when we look at controllers and views. Angular is just kind of plain functions, plain JavaScript objects, and it kind of helps you along the way with those things. So now, we're talking about remote objects now. These are objects that need to talk to your remote APIs to get data. If we look at the Backbone one here, it becomes slightly more interesting. We add a URL root to the beer model so it knows where to go, and this will automatically append /ID at the end of it if one exists in the model. And Backbone is expecting on it through its adapter rather, that you're going to be giving it a RESTful JSON API, very similar to what Ruby on Rails would spit out. So that's something to keep in mind. You got to make sure that unless your JSON API, if your JSON API doesn't jive with that, then you need to write your own kind of adapter and handle that. In the beers collection here, I had to override the URL function to kind of create a more custom set of URLs for me here. And when we look at Ember, the Ember model doesn't change, which is really, really nice. But we do need to set up its REST adapter and kind of configure that just a little bit using some configuration properties here, which is what we see. So for Angular, there's two different ways we can do it. This is an example of the ng resource library that comes with Angular, and it's kind of a nice way to kind of wrap around some of the kind of common things you do when talking to RESTful resources. You don't have to use this as an underlying HTTP library that's a bit more like jQuery's library, but I prefer these RESTful resources using the ng resource library. Just lets you kind of encapsulate that in one place, which is quite nice. So let's talk about routers now. I think routers are definitely a good indication of what kind of framework you're looking at. So routers are used internally when a request comes into the JavaScript framework. Is used to route to different controllers or views and render different parts of your page. The Backbone router is fairly basic yet bizarrely complex. That's even possible. One of the things you notice with this router here, in the routes object, I define a couple routes and then some functions that are going to get called. And when we look at those functions, I'm calling another function that I wrote called change view. And the reason I do this is one of the problems that Backbone has as a framework is you have to basically do your own memory management. It won't clean up views or objects for you. So it's very possible to get into a situation where you've used a form to edit one object, and then you're going to reuse that form again, and now you actually have two objects bound to that form, which can cause a lot of issues, as you can imagine, under the covers. So you have to deal with your own memory management. And that's what's happening in this router here. I'm kind of removing old views, tearing down old views, adding new views. And you'll also notice that I'm actually, in this router, actually sticking stuff, using jQuery to update the HTML on my page with the new view. Backbone kind of requires that, won't do that for you. So something to keep in mind. When we look at Ember, Ember by far has the nicest styled router of any JavaScript framework I have seen to date. It kind of models itself a little bit off the Ruby on Rails router. So if you're familiar with that, the Ember router will look very, very familiar to you. This is the same kind of router pattern that we saw in the last one. I'm mapping those couple parameters, but Ember is going to know, when I do this, it's going to expect certain controllers to be named certain things and certain route objects to be named certain things in order to find them and map them. You can override that, but it's not all that easy. And just real quick, I also wanted to show, since we're talking about routers, there's a route object for Ember as well. Again, that kind of, when I talked a little bit earlier about there's, Ember it can be a little confusing at times. There's routes, there's controllers, there's views, there's templates, and other types of objects. And knowing where to put which thing can be a bit daunting for first-time Ember developers, but it's worth getting to know because the convention does help you write, really great applications with just a few lines of code once you figure that out. But Angular, again, it kind of goes with this more JavaScript approach to just kind of plain old JavaScript. We have this route provider object that has a couple functions called, one is called when, the other one is called otherwise. And in those when calls, you just give it a pattern. When it matches this brewery /ID, I want it to call this controller and this template URL. And there's a lot of options you can put in here as well. These are kind of the ones I use all the time, but you can do inline controllers with just a plain old JavaScript function and a lot more. So the Angular router is very powerful, but doesn't have quite the nice syntax that the Ember router does. Okay, so let's look at controllers and views here. So we're going to look here. We're going to look at the same controller, and we're going to look at three pieces we're going to look for three pieces of functionality in these controllers and views. The first piece is rendering a template and binding to that template. The second one is data binding. In particular, updating as we update a text field. I want to update an H2 tag to reflect that. And the third thing is saving the object that is attached to that form back to the server. So that's what we're going to kind of compare through these next couple slides. So looking at the Backbone one here, this is by far the most complex of the three of them, and I've omitted code that wasn't relevant to this discussion at hand. So again, I have to extend this Backbone view, which gives me some basic functionality. I can define some events, so when someone clicks the Save button, for example, I want to call the Save Click function. And as somebody types in that text field, I want to call a function called title edited. That's because Backbone doesn't give us any sort of data binding at all. We have to manage all of our own data binding if we want to do that sort of live dynamic typing thing that you see in a lot of these kind of sexier demos. In terms of rendering templates, there is no real functionality built into Backbone to do that. I like to roll my own functions, usually called render template, which takes a template and uses the JST library to compile it with objects from my current view, and then I get the HTML of that, and I have to put the HTML of that manually onto my page. That's the way Backbone does that. So in terms of saving the object, when that button gets clicked, that map happens, and the save click function gets called. And in there, we have to collect up using jQuery all the values from the form that we need. We kind of put those into a JavaScript object. We can then call save, giving it those updated attributes. And then we can define a couple callbacks, a success callback and an error callback. And in case of success, I'm just going to navigate the page back to the kind of show version of the page. And in the case of errors, I'm going to loop through and build a giant alert box for sake of brevity here. So now if we look at the Ember one's really nice and sexy because all we have is a save function, and inside the save function we call commit on the store object. Now where that store object comes from, I'll leave that up as an exercise to you, the reader, but it kind of happens automatically. Again, this is part of that convention or configuration that Ember touts so successfully here. You just call this commit and it's just going to happen. Now, what I'm not showing here is kind of error code around that commit. But you notice there's also no rendering code here. That's because Ember expects templates to be named certain things in certain places and will automatically render them for you. And there's no data binding code here because, again, Ember will do that for you, and we'll look at the HTML for that in a second and see how that actually happens. Angular, now this code I actually put the entire code for this whole controller here. This is it. There's no code omitted from this controller at all because it was so short, I thought. I kind of create a plain old JavaScript function that takes in a few helpers because Angular is all about dependency injection. So we're going to inject a scope, some parameters, location, the brewery object. We're going to get the brewery object, and then we have the save function that can get called when someone clicks on that button. And it does the same thing that the Backbone function does, but you can see because of data binding, we don't have to collect up attributes. And because of data binding, I can just kind of set this errors object, if there is an error, onto my scope, and my template will reprint itself to print out errors from the template. So nice and succinct little code there. So moving on, let's talk about templates, an important part of building any sort of web application. All right, so here is a Backbone template. I'm using the Eco library, which is embedded CoffeeScript, and it's very similar to kind of JSP or ASP or ERB if you're familiar with those sorts of syntaxes here. And I'm just going to zoom in a little bit on a couple little sections here real quick. The input tag, you can see there's no data binding, so again we have to just inject our values, our object's values straight into the value on the input tag, which can cause some problems down the line with escaping and other issues. And the same thing for something like a text area. Now, we don't have to do anything special with our button click because we've already mapped that in our view. When we look at Ember, one of the things you notice about Ember is because it's using handlebars, lots of squiggly lines all over the place, with all sorts of curly braces everywhere. To do our binding for our input tag, we have to use a special Ember helper, an Ember text field helper. We can't just use a straight input tag. Ember gives us all these kind of special objects to embed these little views inside of our templates. And when it comes to a button, we can decorate the button with this kind of action helper and tell it to call the save function when it's done. So Angular, here, if we zoom in a little bit, let's just go back to using standard input fields, standard HTML attributes, which is great. And we can decorate it using Angular directives. So in this case, I've got an input tag here, and it's decorated with the ng model directive, and we're telling it to bind to this model in the server, brewery, and then the title attribute of that brewery model that's in our controller that we looked at earlier. And if we look at the button click, is an ng click directive we can use, and so when that button gets clicked, it's going to call the save function from our controller earlier. So you can see in all of those patterns there, and we looked at Backbone, Ember, and Angular, you can see their philosophies. Again, Backbone didn't give us any binding, any way to input stuff into our template. We had to do all that manually. Ember lets us, gives us data binding, gives us great ways to do that sort of stuff. We have to use their custom objects. And then finally, when it came to Angular, we had to use we got to use straight HTML and just decorate it with HTML style directives. So again, kind of plain old JavaScript, plain old HTML for Angular. So to kind of wrap it up here, we can quick look at the pros and cons of each of these. I'm not going to read them all to you, but basically, I think you kind of saw it. Backbone provides this very, very minimal set of helpers. It's great for writing small little widget type of apps. You have a little weather widget, a little Twitter widget perhaps off on the side of your page. It's pretty good for that. The source code is really easy to read. You can read it over lunch. You could probably write it over dinner. The cons, kind of too many to really list here. Unfortunately, it's too simple. It doesn't give you enough. You really, to get the most out of it, you have to use other frameworks that sit on top of Backbone. And when you have frameworks on top of frameworks, I think you've got a problem right there. And eventually, if you write large apps, which I've done, it leads to spaghetti code. It gets way too complex trying to manage all that memory and manage what's happening in your code. Ember is, it's a very structured, very highly opinionated app. If you agree with those opinions, you're going to go far in the Ember community. It really, if you agree with them, your apps, you can write really great apps really, really fast. With a minimal amount of code, which is fantastic. However, if you don't agree with them, it's very difficult, and you'll find yourself kind of butting heads with it the entire time, and it won't be a very pleasant experience. It's very heavyweight, as we looked at. It's half a meg uncompressed, which is really a lot of data. It doesn't have a very big mind share outside of Rails, so that's something to be to consider. And the source code is very difficult to read. But if you're writing large apps and you like these configurations, I would definitely look at Ember. In terms of Angular, I think Angular probably has the most pros and the least amount of cons. Because it's plain JavaScript, you kind of know what you're getting into right from the beginning. It's a pretty easy learning curve. The code is fairly lightweight, as we saw. And it's very, very powerful. You can do a lot with it. It's an incredibly powerful framework. The con side, if you're writing jQuery, you have to write directives around your jQuery. One of the philosophies that Angular has is don't put view-level code in your controllers, which I think is fantastic. So you notice there was no HTML or jQuery calls in my controller code. But the large apps require a lot of self-structuring too, because it's not a highly opinionated framework. So with that, in summary here, think before you choose. Don't just cargo cult. Really investigate each of these frameworks. Don't use Backbone. I think you probably spotted the moldy orange right from the beginning in this talk here. But seriously, sit down, play with them all, find the one that works best for you. And if you're interested, go to metacast.tv and you can watch me build all 3 applications using the same frameworks. And that is it. Thank you all very much for attending. I appreciate it.
Excellent presentation, Mark. Thank you so much for sharing all your knowledge and expertise with us today. We do have a couple audience questions that have come in. So folks, if we do not get to all the questions that came in, because you did have quite a few, there is Mark's contact information right there in front of you on the screen. You could tweet him, visit his website, and follow up with him there. Alrighty, we'll take a question here from Zachary. What's your take on Meteor.js? Why is it rarely included in these JS framework comparisons?
That's a great question, Zachary. So yeah, Meteor is very interesting. It's not for me, I can tell you that much. And I think it's rarely included in these comparisons because it doesn't have the mind share that these 3 particular frameworks have. You notice I didn't even include Knockout, I didn't include Batman.js. There's a large number of these frameworks. And Meteor is just one of them. And unfortunately, it doesn't have large mind share. And I think part of what makes Meteor so great, or so interesting rather, is also one of the things that keeps it from being included. The whole, writing that you write your back end with your front end at the same time, which is what makes for a really sexy and killer demo. But I think a lot of people have certain back end systems that they like to work with. Rails or PHP or Java or Go, what have you. And obviously you can't do that with Meteor. Meteor also currently is, I believe, still just hosted by, you can only host it with them, which makes that problematic as well for real professional applications. So I think part of the problem is it's just not professional ready at this point. They did receive large amount of money to make it ready for production, about $10 or $11 million, I think, maybe about six months, a year ago. So keep an eye on it, but I think that's why it doesn't get in there. I hope that answers the question.
Thank you, and we'll take one more here. This one's from Lionel. How would Knockout compare with these frameworks?
That's a great question. So I think Knockout is kind of somewhere, feature-wise and kind of the way it's written, I would say it's somewhere between Backbone and Angular. Again, mindshare is very, very small compared to these other ones. Look at just using Ember as an example. Ember has a small amount of mindshare when compared to Angular or even Backbone, and Knockout is a much smaller mindshare compared to that. So it's an interesting framework. I think mindshare to me is always a very important issue because I want to know there's a community there. I want to know there's support there. I want to know that there's plugins, there's great libraries wrapping it, there's great articles out there. So that's kind of why I think Knockout, just like Meteor, doesn't get included a lot of the times, is the mindshare isn't there. Backbone kind of does what it does better than Knockout does, and Angular does what it does better than Knockout does. And so Knockout being a hybrid of the two, it's just not getting the best of both worlds, I think. So that's my opinion on that.
Excellent. Thank you so much for joining us today and for, again, that great talk and sharing all your knowledge and expertise. Folks, I'm going to turn the event back over now to Simon and Peter.
Yeah. For our next talk, I'm delighted to have Laura Swanson. She's the engineering manager for mobile web at Etsy, to talk about front-end page speed. One thing I keep finding is that you can have a beautiful site with an intuitive interface, but it isn't enough if it's slow. So she's here to help us all fix that. So thank you. Laura?
Good morning. Thank you, Simon, for that intro. I really appreciate it. As he just mentioned, my name is Laura, and we're going to cover image, font, and markup optimizations that you can make to improve page load time on your site. I want to point out that you can actually follow these slides and all of the links to the resources that I'm going to mention if you go to lauraswanson.com/design. So picture this. You're waiting across the street. You push this button, and you probably do the same thing that everybody does next. You take out your phone. You have a very short amount of time, so what do? Maybe check your email or Twitter, maybe follow a saved link. This short amount of time is exactly why page speed is so important. You want to help your users accomplish what they need to do on your site quickly. Web performance absolutely is user experience. It's being factored into search engine results, and its effects on user behavior are being studied by major sites. We're talking about things in milliseconds, not seconds. That's how granular web performance becomes. Imagine a site as big as Google losing 20% of revenue and traffic due to just half a second increase in page load time. Or a site as big as Amazon. This stat compounded. Each additional 100 milliseconds decreased sales. Users are less likely to be able to complete transactions on slower websites, but also are less likely to have the patience to wait. This doesn't just have revenue impact. Great improvements from page load time optimization apply to any kind of site. Users will return to a site that they don't have problems with, like in this study by Google Maps that saw an increase in traffic when they reduced the page weight from 100 kilobytes to 80 kilobytes. If you're looking for a benchmark, this is it. Users expect your pages to load in 2 seconds. And after 3 seconds, 40% of your users will abandon your site. Think about how you search for things on the web. How quick are you to close a tab and go to the next search engine result if a site takes too long to load? This is evidenced by a recent experiment that we ran at Etsy. We found an increased bounce rate of about 12% on mobile if we added just 160 kilobytes of images to a page. DoubleClick removed one client-side redirect and saw a 12% increase in click-through rate on mobile devices. So again, envision the time it takes for someone to wait for a walk signal to turn or to wait for a bus signal to pull up. That's the time a user has to complete a task on your site. Is your site fast enough for users to accomplish the one thing that they want to do? 75% of shoppers who experience an issue won't buy from that site. That could be freezing, crashing, taking too long, or having a convoluted checkout process. User experience will absolutely drive traffic and conversions away. Performance and user experience go hand in hand. At peak traffic times, more than 56% of online consumers will leave for a competitor's site rather than suffer delays. So what traffic might you be losing to a competitor because your site is too slow? These numbers matter because we are designing sites with increasingly rich content, lots of dynamic elements, larger JavaScript files, beautiful animations, complex graphics, etc. We may optimize design and layout for mobile, but we don't always design for optimized page speed on mobile. Some responsively designed sites are irresponsible with the amount of JavaScript and images loaded to reformat a site for smaller screen sizes. That fast page load time and positive user experience will build trust in your site. You'll get more returning visitors. You'll see more users trusting your brand over a competitor. That positive user experience yields a ton of good things for you and your site, and optimized page speed is a huge part of it. Sometimes we'll make choices that favor page load time, and other times you'll make choices that favor aesthetics. The key is to always be thinking in terms of engagement metrics and what will have the biggest impact. So think about your most recent design. How many different font weights did you use? How many images did you use? How large were those image files, and what file formats did you use? How did your design affect the plan for markup and CSS structure? So for everything we're going to talk about today, I'm going to recommend some good questions for you to ask yourself as you design. For example, if you look at Etsy's homepage, we would ask, what value does this large hero image add? I'd ask if these 3 font weights will help drive conversions. Or what metric are we hoping will improve with this carousel? Aesthetics absolutely contribute to overall conversion rate, just like performance. That's why we should be thinking about this stuff from the design stage and be benchmarking it as we go. So what are we optimizing for when we're talking about performance? This is a good time to bench a web page test, which is my personal go-to tool for measuring performance. You can enter any live URL and choose a geographic location and which browser you want to test. It'll show you things like waterfalls. A waterfall will show you the images and other files that make up the total page load time. You can spot page load time issues by checking your site's waterfall with Web Page Test. This shows the connections made to go grab those requests and render them on the page. Browsers are smart and try to parallelize grabbing those files to show things on the page faster. The vertical green line shows when the page starts to render, and the blue line shows when the document rendering is complete. We're also aiming to optimize the size of each request. Here are some examples of CSS and image files that we load on Etsy.com homepage and how large they are, ranging from just 8K to more than 70K. The bigger each request is, the longer it will take for the page to complete rendering. So here's what we're going to walk through. The biggest wins that you can optimize for include image formatting, size, and spriting, cutting down on font weights, semantic markup and repurposability, and deliberate asset loading. So we're going to start with image formatting because it's arguably the most easy win, since images make up the majority of most sites' page weight. Just so everybody's on the same page, we're going to walk through the different kinds of image file types that we recommend. PNGs, you'll use them for transparency or when there are a few colors. As you know, we use JPEGs for photos and other images with tons of colors, and they do not support transparency. And GIFs, or GIFs. They're very heavy, and most animations can be replaced with CSS3. So when it comes to choosing which PNG, you want to think about how many colors you need, what kind of transparency you need, and how those things affect file size. With PNG8s, you can have a maximum of 256 colors in your image. It uses alpha transparency, and this generally results in a smaller file size. For PNG24s, you get prettier transparency and tons more colors, but this generally results in a larger file size. As you get ready to export your image, test out a few different qualities and file types in a Save for Web workflow in Photoshop. Find a happy medium of quality and file size. Most people find that for JPEGs, 80 to 90% is best practice, but it's important to play with the file size and just to see what looks best. After you've exported the image, run it through a tool like ImageOptim, which finds the best compression technique for a variety of file types. There's also Smushit, which is an online image lossless optimizer. I found ImageOptim saves me a ton of additional file size, sometimes upwards of a 30% improvement on PNGs and JPEGs. You can also decrease the number of requests on a page by combining images into sprites. Your page weight might get bigger because of the larger image in CSS, but it's likely that this will have a huge impact on page speed. In this case study, my team sprited 26 thumbnails on a home page that rotated in and out of these 10 spots. It added 60K to the page weight because of the heavier image, CSS, and JavaScript needed to adjust rotating a sprite instead of using separate images, but we ended up cutting page load time by 35% because we eliminated all of those extra image requests. So good questions to ask yourself. How compressed can this image be? How many colors are needed? Do I need transparency? And can I sprite it? There's an interesting side effect as well to optimized images, which is handset battery life. A recent study showed that if Amazon changed all of their images to compressed JPEG files, it would save 20% of the energy needed to load the page on a phone, which is a significant energy savings. On Facebook, it would save 30%. So we're not just saving page load time, you're also affecting the entire user experience, including battery life. So pop quiz for you. What file type would you use for the backgrounds on these buttons? A PNG? A GIF? A JPEG? Nope, it's a trap. It's CSS3. CSS3 gradients are amazing. They can handle transparency. They can be overlaid on a background color. They eliminate an image request, and they're super easy to re-edit later if you need to change something about it. You can see in the CSS that we're choosing colors and the direction of the gradient. No image requests are needed. Using CSS3 can be a great performant replacement for images. It does require using vendor prefixes currently, but we'll get rid of those eventually. So don't worry about all the extra page weight from the vendor prefixes. You should be using gzip on your site, and that'll take care of optimizing this code. Even though there's more CSS, it'll still generally be a more performant option than an image request. You can do some pretty amazing things with CSS3 gradients because of the control over where the colors begin and end. All of these designs were created using CSS3. That being said, be careful of how your CSS affects repaint times, as there can be a cost to using a lot of CSS. A repaint is an expensive operation performance-wise and can make your page look sluggish, which you really want to avoid. If you find that your user interface becomes sluggish, especially upon scrolling, you may have a CSS3 or a JavaScript repaint issue, and you'll want to dig into DevTools to diagnose what's causing it. So good questions to ask yourself. Can any of my images be replaced with gradients? Will this gradient work over multiple background colors? Does this already exist in my CSS so I can repurpose it? And after you implement it, is there any UI sluggishness that could be due to repaint times? Next up, fonts. Font files can be incredibly heavy and also tricky to optimize for requests. It's important to pay attention to how they're affecting your page load time. Poor IE8. It's not really all that smart with fonts, even if you're not using a particular font file on a page. If it's in your CSS, it'll download them all. This is true for IE9 and higher with compatibility mode on too. This has everything to do with optimizing the size and number of requests. The more font weights you use, the longer the page will take to load, because font files can be heavy. The average font served by Google Web Fonts is about 35 kilobytes, but can be upwards of 200 depending upon language and character support. You can make optimizations to them using tools like Font Scroll's Font Face Generator to remove unnecessary characters, which is also called character subsetting. One more advanced option is to AJAX in a separate style sheet that declares the font. Test this and see if it works for you and your site. So good questions to ask yourself. Which font weights do I need in this design? Can any of the weights be combined or consolidated? And can I remove any of the characters to decrease the file size of my font files? As you design a new project, semantics and the repurposability of what you design are tremendously important. You'll actually save development and page load time by thinking about repurposability of what you're designing and by coding it so it can be reused easily. Bloated HTML leads to bloated CSS and vice versa. I did a site cleanup in which simply renaming elements and cleaning up unnecessary elements, also known as divitis, to focus on repurposability had a huge impact on HTML, CSS, and image sizes. Naturally, this had an impact on performance too. So as you're designing and developing, ask yourself, can someone else use this pattern? Assets that get reused can get cached, which is a huge performance win. Name elements by function or content, not by design. This is debated in our industry, but it's my main recommendation for a small or medium-sized site. A site as big as Facebook should use a naming pattern that's object-oriented because of its scale and how many developers are touching the code. But for your average site, being semantic with your element names can be hugely beneficial for your purposability and eliminating unnecessary elements. Inefficient selectors tend to happen because of CSS overriding previous CSS. It tends to mean that something else is wrong and could be more efficient. It used to be thought that inefficient selectors were just inherently bad for performance, but that's less of a concern these days with modern browsers. It is still good to clean them up as they can help you maintain your front-end architecture. Lastly, again with divitis, you should go through and remove any unnecessary elements. This is a before and after of a site cleanup using Firefox's 3D view of a page. It shows the elements used to make up your HTML hierarchy and nesting depth. The after on the right has fewer layers since we were careful about removing extraneous markup and using semantic markup. So good questions to ask yourself. Did I create a design pattern that can be repurposed? Did I use semantic element names and a good HTML hierarchy? And can my work be repurposed by someone else on another project? Everything we already covered will help you create a performance site, whether or not you use responsive web design. However, there are some additional performance considerations when you implement responsive web. A result of recent client studies showed that for a ton of Internet users globally, mobile is the primary access method. Roughly 50% of Internet users in Africa and Asia are mobile only, which is in contrast to about 25% in the United States. This study called mobile-only users those who never or infrequently use the desktop Internet, and the study included tablets in the desktop category. So lots of people are primarily using mobile devices, and they're so much slower than desktop. Before a device can transmit or receive data, it has to establish a radio channel with the network. This can take several seconds. The best part is, if there's no data transmitted or received, after a timeout, the channel will go idle, which requires a new channel to be established. This can obviously wreak havoc on your web page load times. On a typical US desktop using Wi-Fi, a request's average round trip takes about 50 milliseconds. On a mobile network, it's more than 300. This is as slow as old dial-up connections. But responsive web design doesn't have to be bad for performance. If you start your development or design workflow by thinking about the project from a mobile perspective first, you may be able to avoid many of the problems that bloated desktop sites tend to face. Designing mobile first can save you time by forcing big questions early, like what the core purpose of your page or site is, and trimming all the other cruft. As you implement responsive web design, you will make choices about your content size as it's displayed to the user. It may be fluid, it may be fixed and changed at certain breakpoints, and you may choose to simply not load certain assets at certain screen sizes. This is why it's important to make sure you are only loading the assets you truly need for a user. One approach to consider is conditional loading. You may have heard the term REST, using responsive web design combined with server-side detection. This takes into account what kind of device the user is on, screen size, touch capabilities, etc., and loads only the content that is necessary for that user to see. Adaptive Images, for example, detects your visitor's screen size and automatically creates, caches, and delivers device-appropriate, rescaled versions of your web page's embedded HTML images. Similarly, lazy loading is another technique you can try, loading assets like images or content when the user requires it. You deliver what's necessary above the fold to the user, and lazy load other things as the user scrolls. However, this can cause problems for screen readers, search bots, and users with JavaScript disabled. Third-party scripts can be a single point of failure for your site if they don't load. But equally importantly, when they do load, they can't drag down the performance of your site. When Google Plus was transitioning from the old button to the new button, the script actually loaded both versions of the sprite, adding page load time to each page on the site where it was used. From left to right here, this was Twitter, Facebook Like, Google Plus, and the old Facebook Share buttons. There's no reason why these things need to load synchronously. They should always be loading asynchronously. If a third party doesn't provide an asynchronous version, you should demand it. Also consider replacing them in responsive web design with simple links that don't have the overhead and are much more in your control for performance optimization. Picturefill is another technique you can use to deliver the correctly sized image to the user. It mimics the proposed picture element, requires a tiny JavaScript file, and works across all browsers. The markup looks like this. You set data source and data meta attributes for image size. Performance-wise, this is great. It provides unique image URLs which can be cached. It starts with the smallest image and requires only one image download for the user, and there's even a fallback for old IE browsers. However, this markup ends up being pretty sizable, and it may be hard to replace in the future if browsers decide on a different universal responsive image solution. But again, all of the image, font, and markup optimizations we covered will also help you tremendously when you approach responsive web design. So, as you design, ask yourself, how many asset requests am I creating? Can I find a way to slim down the number of assets I'm loading? Are my images really large or not sprited? Can any be replaced with CSS3? How can I be smart about weighing aesthetics versus performance, especially when it comes to heavy assets like fonts? What can I repurpose so that it's cached for the user, or so it helps with device and the size of my markup? An additional recommendation I have when approaching a new project is to create a performance budget, such as a total page weight limit or a total page load time goal. By creating a performance budget up front, you can have an easy baseline to refer to as you design and develop. If you say that you want the page to be loading under 2 seconds, you can continue to play with the balance of aesthetics and performance and decide what works best to meet that goal. I also recommend you get your designs into the browser as soon as possible. Photoshop is an unrealistic way of gauging how effective the design will be once it exists in its final environment, and you can start to see how large your page weight is and how your design decisions affect performance quickly. Lastly, continuing to iterate on existing designs with performance in mind. If you want to make some aesthetic decisions that negatively impact performance, A/B test them to see which one actually improves your engagement metrics. Continue to benchmark and iterate on performance as well as engagement metrics as you make any changes to your design. As Brad Frost says, good performance is good design. There's a ton of other improvements you can make on the back end, but 80 to 90% of the end user response time is spent on the front end. On mobile, it can be upwards of 97%. So optimize for good performance, and you'll have a huge leg up on creating an excellent user experience. Thank you.
Thank you so much, Laura. That was an excellent presentation. And boy, oh boy, we have so many questions coming in for you. So folks, we are going to first push out Laura's Twitter handle. So we're going to let folks know they can follow you on Twitter and connect up with you there. And folks, we're going to take just a couple of questions here as time is going by. Okay, let's take a question that came in from Josh. Josh would like to know, what is an optimal number of web fonts we should load on a site to strike a good balance between performance and style?
That's a really great question. So at SE, this is something that we're actually continuing to experiment on. Right now on mobile web views, we actually recommend loading 0 web fonts just because it has such a huge impact on performance. On desktop views, we're experimenting with between 1 and 3 web fonts, but again, we're measuring engagement metrics as much as we're measuring performance to see if we can strike that balance.
Thank you. Question here from Ashley. You mentioned the large carousel on Etsy's homepage. What metrics do you have to support using that much space for solid graphics instead of links or content?
That is an excellent question. So carousels are a funny thing. When we look at primarily Etsy when we're running an experiment, our conversion rate, we also look at favoriting and other engagement metrics like time on site, pages per visit, and the general checkout workflow. So we measure all of those things with every experiment, including looking at the carousel on the homepage.
Perfect. And we'll take our final question from Jose. Which CSS prep processor do you think delivers more optimized or lightweight CSS files?
That's a great question. Actually, there's plenty of resources out there about which CSS preprocessors might be right for you. Currently, we're not using any at Etsy, but we're starting to explore different ones that we could use for our development workflow.
Perfect. Thank you so much, Laura. And folks, we pushed out a link to Laura's talk at the Fluent conference and hope you'll take a look at that. And at this time, I will turn the program back over to your conference chairs, Peter and Simon.
Thank you, Yasmina, and thank you, Laura. It was a great talk. Moving swiftly on. It is a pleasure to introduce Mark Grabansky. He has the full geek cred. He was the original creator of the jQuery UI date picker, but he's perhaps better known now for teaching, and he does videos. He has a company basically called Front End Masters where he does this. And he works a lot with SVG, which makes him very well qualified to give this next talk, which is a whirlwind tour of scalable vector graphics. SVG being an increasingly important thing, even though it sort of was originally developed back in the late 90s. It's become increasingly more important because of its role in responsive web design and its role on high DPI devices and things that I suspect that Mark is going to mention. So without further ado, hi Mark.
Hello.
Hi, Mark. Mark, are you able to hear us?
Yeah, I'm having trouble with the slides. I'm going to reconnect in Firefox.
Okay, folks, just a moment here. We'll have Mark reconnected. And while he's doing that, let's see. Laura, are you still on the line?
I am still on the line.
Okay, would you like to take a couple additional questions?
Yeah, I'd be happy to.
Okay, let me pick a few here. We've got Israel would like to know, do you prefer using classes over IDs when building your CSS code?
This is another thing that's hotly debated in our industry. I do use IDs actually in my own code, but I'm really intentional about when I use them and why I'm using them. Obviously, IDs are going to carry more weight in your CSS, and so that can be beneficial, but you shouldn't be using them just to override existing styles or just because you think it's only going to be used once. At Etsy, because we've got such a large code base and because we repurpose a lot of material, classes end up being much more widely used just because we ended up repurposing so many assets.
Perfect, thank you. And folks, as we wait for Mark Grabansky to reconnect on his end there, we do want to mention that we do have a terrific code for you all. There's still time to save 20% on your Fluent conference registration by December 19th, okay? So use code WEBCAST. Write that down, WEBCAST, to save. We pushed out a link to you all in the group chat. Please do take advantage of that. Boy, oh boy, if you like what you're hearing today, there is so much more going to happen at the conference, and we hope you do take advantage of that discount. Okay, and Laurent, we'll take one more final question here from...
I think I'm good, but...
Oh, are you back? Okay, thank you, Laura.
Yeah,
back
yeah,
to
no
you,
problem. Thank you.
All right. Everybody can hear me fine?
We can hear you.
Excellent. All right. So you're here for lots of stuff on JavaScript and the web platform, but what I'm focused on today is scalable vector graphics. And this is a way for you to have a visual asset that can scale up and scale down and be able to be displayed well on mobile, as well as if you really want to, you can print it and put it on a billboard. So who am I? Like Peter mentioned, I created the JavaScript component, the jQuery UI date picker. For a long time, I blogged on markavansky.com, but currently I'm just building quite a few user interface web applications on primarily SVG right now, but I have done jQuery mobile and probably 40 or 50 different major web applications. Right now I run Front End Masters, as Peter mentioned, frontendmasters.com. Basically we hold workshops and then we turn those into video, and it's a subscription platform where you can get access to people like Douglas Crockford and just so many amazing people that came out to do that. So I'm doing that ongoing and building web applications. So as far as SVG is concerned, I've built a couple major applications on SVG, and this is kind of we'll start out with the core essentials of what you need to know about SVG, what elements are at play, and then hopefully we'll get to some demos later on, before questions and stuff like that with the screen sharing, if that works. So some of the advantages of SVG, one size does fit all in the sense that you can scale these up and scale them down. Of course, if you want to make high fidelity graphics for a specific size, like an icon or something, you'll want to develop it for that size. But for simple things that you want to scale up and scale down, SVG has that advantage. It's also basically it's got HTML like tags for graphics. I mean that's the best way that I've heard SVG described is these are tags that describe graphics, just like you would in DOM. You can describe a graphic with an SVG element. It's got the DOM structure, so unlike Canvas where you're drawing to one surface, you actually have these specific elements and hierarchy like you would in the normal web browser with HTML. So you can also use CSS3 on it, and you also have all sorts of JavaScript events. The JavaScript event model and everything works inside of SVG. Search engines can parse it. It's accessible. You can add a title and description tag to each element and add some accessibility that way. It's printer friendly. So in the case of one of my clients, they actually build up all of their graphics in SVG, and then they can send that out to the printer. It has really good browser coverage, and we'll get into more into each of one of these points. So this is an overview of the benefits, and let's dive into each one of these benefits. So one, SVG fits all. So as you're scaling a bitmap, you actually have to add more pixel data. So if you want something to go from really small all the way up to really big, with regular bitmap graphics like JPEGs and GIFs and PNGs, you're going to actually have to add more pixel data, which increases the file size. And as in the previous talk we were talking about performance, you want to keep the amount of data to a minimum. So SVG is a great alternative to that. You can create one graphic and obviously scale it up and scale it down. So let's look at, so if we took a a PNG, zoomed it up, it's obviously going to look all, gross, but with the SVG zoomed in, it actually looks crisp and clear. So let's dive into these graphical tags. As I mentioned, it's HTML-like markup for graphics. So here's the text element. You just specify an X and a Y. And the X actually starts at the left and the Y at the very top. So 0, 0 would be the top left, and you just go from there. With the circle, when I first looked at this, I guess I didn't know what the CX and CY was, but that's actually the center of the circle. So the center X and center Y of the circle, and then radius is 200, so it'll make diameter 400. We have a rectangle, which you could start with X and Y, and width and height, and you'll see it added this fill attribute. And the fill attribute, just obviously you can specify the color, but that's new with vector graphics versus, let's say a background color with HTML. The ellipse, you specify a radius of X and radius of Y. So in this case, the width X is twice the height, so we get a ellipse that's wider than it is tall. The line, you basically just specify an X, starting X and Y, and ending X and Y, and you'll see two new attributes here I'm showing, which is stroke and stroke width. So in this case, if you want the line to be 25 points wide of a stroke, you'd add stroke width. And what's nice about these attributes is you can actually put them in your CSS. So with styling SVG, since you can use CSS against SVG, you can just add stroke property in your CSS. We've got a polygon, and this polygon, you'll see this star actually has 11 points, but in this, in the points attribute, we've got 10 X and Y pairs. And the reason that there's 11 points and that whole thing is filled is because between the first and last point, it will actually close that path into a polygon. And in that way, you can, fill the element. So we've also got a polyline, and so the difference between the polygon and the polyline is the polyline won't fill itself. So you just draw out all the points, and it's not going to fill. So in this case, it's drawing basically a line, and we can add the stroke to it. The path element is actually the biggest strength, I think, of SVG, because when you'll see any sort of complex vector graphics, a lot of things that were drawn with Illustrator, you can create, amazing, pretty detailed graphics with this path element. And the path element is command-driven, so if you've used a tool like Illustrator, you can add these control points. And so with the commands, you just put like an M is moved to, and then your X and Y, and then C is curved to, and that would specify your two X and Y control points, or your first two control points, and then your X and Y of where it's going to curve to. And so in this case, we're just drawing a curved shape with the path element. And so the key here is just you've got these commands, and you can put it at this D attribute and draw really robust different shapes. There's a G tag, so like div in HTML, we can use a G tag, and this G tag just kind of, obviously it's group of elements, but the difference between, say, a div tag in HTML and a group tag in SVG is if you add these attributes to the group tag, it will propagate down and add those attributes to those attributes to its children element. So in this case, we're adding a fill of an RGBA value, but that fill is actually going to apply to the rectangle and to the ellipse. And since we have 30% opacity, where they cross, we're actually getting 60% opacity because they're both gray, 30% opacity, and then obviously we've rotated them, and the stroke is added to both of these elements. So I mentioned that it's a DOM structure, so you can actually go in and use Chrome DevTools and inspect each of these elements, these graphical elements, and this has saved me in projects. Whereas Canvas, if you draw anything complex with Canvas, it's going to be hard to sort of debug. You have to do everything in code. In this case, we're used to working with elements and HTML and changing properties on the fly, and you can do all of that with SVG. You can just inspect the element. You can change the properties, see how it affects it. It's excellent. So how do we actually go about using SVG? So there's a number of different ways. Here's 4 of them, and I'm just going to blaze through the 4 ways that you can use SVG here. So you can embed it with an object tag. This, if you need, say, support, or if you need a fallback for old browsers, a lot of times this is how it's used. So you would load the SVG, and then inside the object tag you'd use your fallback. So SVG is supported in IE9+, but IE7 and 8 don't support it. So any browser that doesn't support the SVG, it'll just fall back to the image. And this is fully scriptable. So like I said, you can add JavaScript in script against elements. You can embed JavaScript inside the SVG. So if you want to get access to its content document, like you would get access to the browser document, you can find that object, and then you can do element.content document, and you have a full object model, and you can just script against it there. This is the new kind of way that's the standard with HTML5. This is fully supported in HTML5, and you can just inline your SVG, just supply a width and a height of your viewing area or of the SVG, and you can just drop a rectangle right in it. It's really easy to start using SVG. Just get up and running. The inline SVG support, as I mentioned, we've got IE7 and 8 don't support it. If you're lucky enough to be able to develop applications where you don't need that support, you can just do it this way. Just embed it right in the document. You can set SVGs as an image source. So if you want to, you can just drop in an SVG as the background of, or as an image and use it that way. But SVG, the JavaScript is disabled if you use it in this way. So browser support with this is really great. You'll see obviously IE8 and less, but across the board you can use SVGs as images. You can use it as a background, so you can use these graphics in your CSS as a background. There's a really cool utility that came out called SVG generation, and I could paste that in the chat here. It's really great because you can walk around. You can generate all these different backgrounds, and it's excellent. So take a look at that. So SVG as a CSS background, again, really great browser support, missing old IE. So, as I mentioned, you can just script against all these elements. So if you've got a polygon, you can add an ID to the polygon and just do document.getElement by ID star, and add an on-click handle or whatever you want to do. So it's just like HTML. This is, to me, just like blew me away, and being able to have a complex path, like in this case I've got the state of Minnesota or the state of Wisconsin. You can get all this data on Wikipedia for countries and states, which has great path or great complex paths, and you can just wrap a link around that and get non-box links. So if you've ever tried to create like an image map in HTML, you don't need to do that anymore. You can just have a path and wrap that path or wrap that group in a link, and that state of Minnesota, that state of Wisconsin, it is clickable, and you can style hover events, and with CSS it's just absolutely brilliant. So here's a demo. I'm not sure if you can actually click on it. Can they click on it? Can you guys click on it? Tell me in chat. You can just Google I Twitty the Fool, and it's a really good example of using an SVG as an image background. And then you can specify the SVG inside the image tag and then use CSS animations. And it's a really great demo. So you can Google I Twitty the Fool and check that out. We've got SVG filters. Hopefully I'll get into SVG filters in my actual talk next, for the actual Fluent Conf. But with SVG filters, you can add incredibly robust effects to vector, and to, if you want to, you can put, really anything in there and apply filters. So we've seen some really cool demos lately of using SVG filters. What it is basically it's just like Photoshop, how you specify blending modes. You can do that with SVG filters, and you can compose them, all the blending modes together, and create incredible effects. So check out SVG Wow filter effects if you want to take a look at that demo. SVG filter support, again, is actually very good. Unfortunately, we're missing IE9, but anything beyond that, it's working well. With working with SVG, you can specify transform attribute, and transform is basically like, scale and rotate and whatnot, and these things stack together. So again, another demo. I didn't realize these weren't going to be clickable, but you can take a look at that pen. Maybe we'll paste it in chat. Someone paste that in chat. It's actually a really cool demo. So here, I pasted it in chat. You can take a look at that, and these transforms kind of stack together, and you can rotate things, move things, etc., and manipulate your SVG that way. And so that's transforms. A lot of times, if you're building anything, any larger SVG application, especially if it's interactive, you're going to run into transforms. So it's good to know about that. So sourcing my sources, one of the big ways that I used SVG is using Raphael. And Dimitri created something new lately called Snap, but Snap is kind of in the early stages. So Raphael is really probably the most mature library at this point for working with SVGs as in full graphics. We're not just talking about circles and squares here. We're talking about the full graphics. So with Raphael, I keep mentioning, SVG doesn't work in IE8 and below. Well, actually, with Raphael, you can use SVG. You can use vector. So Raphael sits in between sort of the the browsers, just like jQuery did. So a lot of times I call it, I call it in the past like the jQuery of vector graphics. The awesome thing about jQuery is we could just write code and it work everywhere. Well, with Raphael, you can write vector graphics and it's actually going to work in old browsers as well. But it has a smaller API because it has to work in between VML, which is the old IE way, and SVG. But it has some great utilities to make working with vector sane, which is what I'm excited about with Snap has a lot of these features. So just running quickly through the features of Raphael, you can create primitives, you can modify attributes, you can manipulate. So like you can do drag events and it'll actually map to touch, which was great. So I made a full SVG application and it worked on iPad. So the transform API here, I think maybe it's a little bit too advanced to get into for this quick, short, half-hour talk, but just know that it's basically command-driven like paths where you just say, T, you can move something, S, you can scale something, R, you can rotate. But I want to get to the demo here of this, where you can use absolute transforms. And this saved me so much headache with Raphael, is you can use these capital letters for transforms, and instead of rotating something and then when you translate it to on the x-axis, with normal SVG, if you rotate something and then you move it to the right, it's going to move based on its new axis. Well, with Raphael, you can actually rotate something and then move it to the right. Just say, move it to the right, and it'll move to the right. And so you can do this in Raphael, you can do this in Snap, and it's just saves a lot of headache. I also have a demo for that on CodePen. You can take a look at that RSVF of using Raphael absolute versus relative transforms. It just saved me a ton of headache. So it's on my CodePen 1 mark. You can take a look at that. Also has more utilities. The matrix split is more advanced stuff working with transforms. The get bbox method here is another really useful utility. So if I want to know where something is right now, you can use get bbox, and you can get its x and its y, its width and its height. And this is fantastic for building interactive applications, because you want to know after all these transforms applied, where is it now? And SVG itself doesn't really give you an API for that. So with Raphael, and I believe with Snap, you can use the get bbox method. We'll dive into some other cool stuff before I head out here. We have 5 minutes. So check out the clown car technique by Estelle Weil. She created it's kind of an alternative to adaptive images. You can specify media queries inside of an SVG, and then just choose which image you're going to load based on the width. And what's nice is it's based on the width of the element instead of the viewport. So typically with adaptive images and stuff, it's all based on the width of the viewport, and in this case, it can be based on the width of the element, which is nice. With SVG icons, there's tons of icons. I'm just showing Raphael icons, but you'll see one of the biggest movements with SVG right now is people are creating amazing icons and amazing interactive icons using libraries like Snap and Raphael and whatnot, or scripting against it directly, where these graphics are stylable and interactive. I would like to paste one amazing demo. Here you go. So this way, those are an amazing set of it's just a good demo of interactive icons. So I pasted that in chat. JSVG, you can pack things, multiple SVGs into one request. Fabric.js, you can render SVG into Canvas. Vectron is a library I created, so you can AJAX in an SVG, parse it into Raphael, and then display it in old browsers. SVG stacks, there's a cool new way to sort of replacement for CSS Sprites. I don't really have time to get into it too much, but with Snap, I mentioned check out Snap SVG. It's sort of the next the predecessor or whatever, their successor to Raphael. So of course Dimitri created Raphael, and now he created Snap. So take a look at it. And D3, a lot of times people, when they associate vector graphics, they think of data visualizations and whatnot. Well, D3 is an amazing library to create incredibly rich, interactive data visualizations. It's not really a vector graphics library per se, but it's a good way to work with tons of circles and squares and paths and geometry. So you can do a lot with geography and stuff like that. So it's amazing. Check out D3 if you want to create interactive data visualizations. Hopefully I'll get into a little bit in my talk at FluentConf, and I hope to see you there. And thanks. This is my Twitter handle if you want to reach out to me. There's tons of questions in chat, I know, so definitely tweet at me, and I'll do my best to answer there.
Thank you very much, Mark. Really fascinating presentation. We'll have time for just a couple of questions here, and we'll take one from Philip. Philip would like to know if you could please discuss how SVG compares to Canvas for performance and efficiency.
I don't know that the conversation should be around performance. I mean, they're kind of two completely different technologies. I mean, Canvas is a bitmap-based rendering surface, so you have to render out each pixel in the canvas. Whereas SVG, you have everything is described in math and markup, just like HTML, and you're rendering it out. So if you have thousands of DOM elements, it would perform similarly to thousands of SVG. Thousands of SVG elements would perform similarly to thousands of DOM elements. Versus Canvas is just one element, and you're sort of painting into it. So I'm not sure that the conversation should be around performance. It should be around what you're trying to actually do with your graphics.
Great, thank you. And it sounds like you're able to view the group chat, so we'll let you follow up with a few of the folks there with questions. And because of the interest of the time, we're going to turn the program back over to Peter and Simon. And up next is Nate Murray. Back to you, gentlemen.
Great. I'm delighted to introduce Nate Murray. He's going to take us into some of the corners of JavaScript that many developers don't actually explore, but maybe we should be visiting a lot more often. He's the co-founder of FullStack.io, and previously he was the head of platform at IFTTT, which, if you don't know, stands for If This, Then That. So, Nate, take us into the AST.
All right. Thank you very much. Can you guys all hear me all right? My talk today is called can you hear me?
Yes.
Fantastic. All right. So this talk is called Manipulating Space-Time Fabric by Rewriting the JavaScript AST. So there's really three things that I want to do. I want to show you a teaching tool that my co-founder Ari and I that we recently made. That one of the main ideas that it teaches is it helps new programmers learn iteration. And then two, I want to show you a real concrete example. We'll dive into some code about how to use Sprimo, which is a really cool tool. So that way you can use that to rewrite JavaScript code. So you can write your own tools, kind of like Chalk, the tool I'm going to show you. And then if we have some time, I'll give you some of my ideas for strategies for teaching people programming, but like really teaching people anything in general. So So first, let's switch over to a demo. Let me set up the screen sharing here. All right. There we go. Can everybody see that demo? All right. So here what we've got right here is a tool that we are calling Chalk. Let's see. I'm getting some reports in the chat that's a black screen. Anybody seeing it? You guys seeing it? Can't see anything.
Did you launch the play button in the lower right-hand corner, Nate?
Yeah, let's see here. Oh no. Well, this is one of the main aspects of the talk. So here, well, what we can actually do. Let's see here. Hold on, give me 1 second. It's a big part of the talk.
Sure. Folks, we're going to let Nate try to reconnect that screen share here for us, and as you can tell, this is a live event, so we do appreciate your patience. Also, just to let you all know, if you didn't open your group chat, please do open it. You can type questions in for today's speakers. Please preface them with a Q so we know that they're for our speakers, and we'll get to as many as we have time for. And also, our Fluent conference is coming up this March 11th through the 13th, and because you're attending our event today, we have a special code for you all to save 20% on your registration if you do it before December 19th. Use code WEBCAST, and you can save that 20%. And if you like what you're hearing and seeing today, we have a lot more that will really mesmerize you, and you'll learn so much at the conference. So we hope to see you there. Okay, let's check in with Nate. How's it going with the screen share?
Well, can you guys see? How about this?
Yeah, I do see something there. If you have a primary monitor that you could designate if you're using two, and are you able to show us some code or a slide or something?
Yeah, here, we'll try one more thing, and then we might just have to move on. How does that look for you guys?
Let's see here.
Still black?
Still
I'm looking
black.
at the chat to see if any... All right, that's no problem. What we're actually going to do is just move on.
Okay. Folks, sorry about that. Sometimes that happens with live events. We do appreciate your patience and sticking with us, and we'll just turn the program back over to Nate.
All right. So here, if you guys check in the chat room, if you guys check into the audience chat, I just pasted a link there. Can you guys see that in there? All right, great. So what this tool is right here, in this link, this is an example of a tool that we use called Chalk. What I want you to do actually is open up that URL and drag the slider back and forth. And what you can actually see is as you're dragging the slider, you can see that the code updates line by line. Every line of the code is being executed as you drag that slider. Can you guys see that URL? Somebody give me some feedback in the chat if you guys can see that URL. Fantastic, fantastic. So as you drag that slider, what you can actually see is you're getting a readable description of the code as you drag each line. What you can actually do is take those constants and you can drag them as well. So if you look at the line that says pad.makeLine, and there's a constant that says 200, click on that constant and drag it back and forth. And what you can actually see is as you are playing with that constant, you can see that that it's actually changing the code in real time. This code is actually fully editable. There's a whole slew of demos that you can actually play with here at this URL/chalk. So here we go. So we're actually just going to move on. I would love to show you this demo. It's really, really cool. It's actually kind of the main part of the talk about this tool that we built, the idea was to be able to teach new programmers how to think procedurally, right? The idea is that a lot of live demos, what they do is they show you the code on the left-hand side, and you see a rendering on the right-hand side, but you don't really get a good sense for what's happening in the middle, right? And it's really hard to understand how code on the left becomes kind of the drawing on the right. And so Chalk is a tool that we've designed to be able to help people get a hold of that concept. So the motivation here really is I wanted to teach my dad how to learn fractals. My dad, he's not a programmer. And when I was a kid, we used to spend hours waiting for our little Mac screensaver to draw a fractal, and particularly the Mandelbrot fractal. And as I've been programming for a while now, I realized that it's actually not that hard to understand how the Mandelbrot fractal is actually drawn, except for two concepts: one, imaginary numbers, and then two, iteration. And so I really wanted a tool so that way I could teach my dad how fractals were created. And so none really exist. And I came across Brett Victor's video essay called Learnable Programming. I highly, highly recommend it. I linked to it in that article. And it was exactly the type of tool that I needed, but it didn't exist, right? And so one of the things that we needed to do is we wanted to accept arbitrary code input. So, you can actually take that first parabola demo, and here I'll paste in chat, and you can actually add you can actually write new code. Like you could say, you can change the color of the line, or you can add new lines. And so the idea was that we needed a flexible tool that we could use to have any type of code, arbitrary code input, and that we could act on that. And so what we needed to do is we needed to control the execution, right? And it's really hard to control the execution of JavaScript from the browser. We really wanted a tool that people could just load up the web page and they would be able to see the interaction right there on their screen. We didn't want to do a browser extension. The most common control of execution that you see is maybe like the Chrome developer tools, the debugger tools. And we didn't want to write a browser extension. We wanted it to just work right away. And we didn't want to write a custom interpreter either. There's a couple actually really cool ones. Check out Meta.js. And there's even Continuum, where they've written like an ES6, like an ECMAScript 6 virtual machine in ECMAScript 3. It's really ridiculous. And so what we decided that what we needed to do is actually take the code that was input, and we wanted to rewrite the code to do what we wanted. We wanted to be able to take line by line and pause the code execution and then give you information about what was actually happening, saying, okay, here's a variable being set, here's a line being drawn, here's a conditional that is true or false. And so what we actually do with Chalk, in that demo, what we actually do is we take the code that you've given us and we actually rewrite it to throw an exception at the particular point that we need, and we add code that actually traces the execution. So you can actually do this too. I mean, this technique is actually really, really useful. And I want to show you how you can parse JavaScript code and how you can kind of rewrite it to do your bidding. So this is really a three-step process, more or less. What you actually want to do is we want to take the original code, and we're going to parse that code. And then we want to search through that code, and we want to annotate that code with any sort of changes that we want to add. And then we're going to emit new code that does whatever we want. So the main tool that we're going to use for doing this is called Esprima. Esprima is a really, really awesome tool. It's written by Arya Hidyat. He spoke at Fluent last year. I think he's speaking this year too. I think he's speaking on API strategies. He's a really brilliant guy. You should definitely check out his talks. And so what Esprima actually does is it parses JavaScript syntax and it transforms it into an abstract syntax tree, or that's an AST for short. And so, like, here's an example, right? Here's what you've got is the expression 3 plus 4. And each expression in JavaScript, each little bit of code that we're familiar with seeing, has actually been assigned like a language construct, almost like a grammar, or a grammar literally, where like 3 plus 4 is a binary expression, and you can see here it has an operator, which is the plus sign, right? And there are 2 nodes under this tree. There's the literal 3 on the left-hand side, and there's the literal 4 on the right-hand side. And every bit of JavaScript code that you write can be parsed into this abstract syntax tree, this AST. So this is like a high-level diagram, but here is a specific example of what the AST looks like when it comes out of Esprima. So if we just have the JavaScript code 3 plus 4, on the right-hand side what we've got is the AST, and it's actually easier if you start from the middle, just real quickly. You can see on the left-hand side we have a literal object and the value is 3. We have on the right-hand side it says literal value 4, and it's wrapped in an expression which is a binary expression, which is wrapped in an expression statement, which is part of the body of our program as a whole. And so here's another example. If we say we have a test where we're saying like, okay, we want to check that foo equals expected, and we're using the assert library. On the right-hand side, this is the AST that matches to the code. Assert equal foo, right? So every bit of JavaScript code that you have has a corresponding like object structure that you can actually manipulate. Okay, so like why might you actually want to do this, right? Like why is this useful? And so the reason that it's useful is because what happens is your code becomes data, and like data that you have as input can become code. And this is an idea that's really familiar to like functional programmers, especially with like Lisp, Clojure, and a language that supports like code being data and data being code really easily. You know, the technical term is like homoiconic, right? And the idea is that when you sort of blur this line between what is code and what is data, you have, you know, as they say, turtles all the way down, and you are able to have your code write code that you couldn't write otherwise. It's this like really high-level, powerful concept that you can write code that will rewrite other code. So some of the applications that you've actually probably seen of this in the wild is for syntax coloring, right? You can take a bit of code, you can parse it, you can break it down into its parts of speech, and then you can color it accordingly. You can use this for code test coverage. You can take your code and you can verify that each individual component is being tested. You can use this for documentation generation. You can actually take, you know, your routers or whatever of your app, and you can generate what the HTTP API documentation might be for that. This is used, not Esprima necessarily all the time, but this approach is used for like minification, right? You can read through a function, find all the variables in a scope, and then rename those variables to a variable that takes up less space. It's used for linting, where you can say, okay, you know, we need to have this sort of, we don't want parentheses if the function doesn't take any arguments or something like that, or if you're like using CoffeeScript. You can also use it for structure matching. This is a really, really interesting example that they're doing at Khan Academy, where they want to take student code as input, but students might use different variable names, right? So you want to actually just look at the structure of what's being input, and you want to verify that it's valid. And so there's a link there at the bottom from the Khan Academy that you can use Esprima to validate that the code is structurally correct, even though specifically there might be variation. So let's go through an example real quick, and I can show you how you can actually use Esprima to build your own tools. So let's say that we want to do this. That we want to take, we've got a test. We've got some test files, and we decided as our team that we want to convert from using the assert library to using should.js, right? So if you guys are familiar, assert is like one of the standard testing libraries, particularly in Node. And if you want to use like the should library, the syntax is a little bit different, even though like operationally they're kind of doing the same thing, right? So what we're actually going to do real quickly is we're going to write a toy tool that will actually convert assert statements into should statements. So right here we've got on the left-hand side the code for assert, for the assert code, and then the corresponding AST, right? So if you look on the inside, you can see you've got a member expression which says assert equal, and then the arguments to this function are foo and the identifier expected, right? And what we want it to be is this target code, foo.should equals expected, and there's the AST on the right-hand side. So the problem of turning this assert statement into a should statement is really just the problem of turning this AST on the left-hand side into turning it into the AST on the right-hand side. And you can see right here some of the mappings accordingly, right? That we want to say foo, that foo matches at this one place in the left-hand side and in the right-hand side, expected on each side. What we want to do is translate this tree into a corresponding, almost a template on the other side. So we're going to use two libraries primarily to do this. So one is Esprima, that parses your code into an ASC. And then the other one we're going to use is ESCogen. And ESCogen actually takes an AST, which is just JavaScript objects, just like any other JavaScript objects that you use. ESCogen takes an AST and it generates textual code from it. Right? And so what we've got here is we're actually taking Esprima and we're parsing our first assert code, assert equal foo. We're calling this function transform assert, which we'll build out in a second. And then that returns a new AST. And then we pass that new AST transformed into ESCogen generate. And then we write out that new code, and we want that to be the same statement as a should statement. So we'll start real small, and we'll just build it up as we go along. So what we want to do is we want to take the input assert statement. We want to take the input assert AST, and what we're actually going to do is we're going to pull out the actual value. So in the assert statement, the actual value, the actual node is this literal foo, right? It is, and how you actually access the AST is just like any other object. And so you can see in this function we're saying call node, which is the top level, dot expression, which is the next level, dot arguments, and then the 0th element, right? So what we're pulling out is the thing that we're testing, the actual value, we're pulling that into that value actual node. And similarly, with the expected node, we're taking the second argument to the assert function, right? Because the assert function is like first what the actual value is, and then what we expected it to be. That's the API of the assert library. And so then what we want to do is we want to create a new AST, right? We're taking the assert library and we're converting it to should. So we need a new AST. So like what should that be, right? And what that should be is the AST of the foo statement. So that AST is right here on the right-hand side. And what we can actually do, instead of actually pasting that whole AST into our code as like a full-blown JavaScript object, if we don't care about performance all that much, which we don't in this toy example, is we can actually use Esprima again to parse almost like a template of code. So you see right here we've got x.should equal y. And we're just parsing that with Esprima. And what we get back from that is a new JavaScript object that we can use as almost a template. And so then what we do from there is we overwrite the values. So if you see expression, callee, object, literal, foo, and we set that to the actual node, right? We reassign the x to the actual node, and similarly, we reassign what we expected to be the first argument of this function, right? We're just translating this tree from what we already have into what we want it to be, just like we would manipulate any other JavaScript object that you might get from, say, an HTTP API or something like that. So with that transform assert function filled out, it works. We can transform exactly this assert equal to a should statement. Okay, but that's nice, but in general, we have a lot more than that, right? We have like assert equal, we have assert not equal, we have assert throws, so maybe we have like a whole function block that eventually throws an exception. And so what we're actually going to do is beef this up just a little bit. And we'll come up with a new function. We'll call this transform assert node. So the same thing as before. We're going to parse the code, we're going to transform it, and then we're going to generate new code. And I'm not going to go through everything here, but this works actually. You can look up these slides. I'll post them afterwards. But the idea here is that what we can actually do in our function is we can have a case statement where we say, okay, if we're looking for equal, we're going to use this sort of template. If we're looking for not equal, we're going to use this sort of template. If we're going to do throws, we're going to use this other sort of template. So one of the really, really interesting things, particularly about throws, which is the third example on this slide, look at this where we say transform assert throws, and there's a function internal to here, and there's a whole bunch of code within that function. But our code to rewrite that throws statement into the should library is actually really, really simple. And the reason is that we're using that because that function is a tree, an object tree. You can reassign it like any other object, and it just works. You can deal with your code instead of as like individual characters where we're parsing it with regular expressions, which is like never going to work. You're actually taking your code as a full-blown object, and you can reassign it wherever you need it to. All right, so you might be saying, okay, that's fine in these toy statements where we've actually got the assert statement right here, right? But how do we even find the asserts in the first place, right? When I actually have my test, I have require statements, and I have, like we're setting up database connections, things like that. So how to actually find asserts? And there's another package that you would use called ES_traverse. And what ES_traverse actually does is it will traverse your AST tree, and then you can use that to actually have conditions where you say, all right, I'm going to search for assert statements, and then you can collect them all together, and then you would run them through that function that we just built. All right, and you would go on and you continue to add it until it's kind of accounted for all of the cases that you're looking for. So here's a couple of ideas that you guys can apply these ideas to. I actually haven't seen tools like this. If you have, let me know. But these are some ideas of things that you could actually work on and use Esprima as a tool to do this. So one is semantic diff, right? When you push a change of code to GitHub, Git in particular, it mainly does line diffs, right? And that's actually not always that useful. Sometimes you might refactor a function into two different functions, and it's really hard to tell kind of like what the actual diff does. What you could do with Esprima is you could parse that code, and you can actually come up with like an intelligent semantic diff, and that would be really, really useful. You could tell the difference between two bits of code in like a logical rather than like a character-based way. Also, you could do similar code detection, right? Because you're parsing your code into a tree. Are you guys familiar with the Levenshtein distance? This is a technique borrowed from like natural language analysis. For Levenshtein distance between two strings is the number of, it's related to the number of operations to transform one string into another, right? So you need to, add a character, delete a character, remove a character, whatever. What you could actually do, the same thing with the tree, is there's an algorithm called tree distance where you can actually say, like, how different are these two trees from each other? And you could actually use Esprima to parse your code base and then detect code that is like similar by shape that possibly could be refactored into a common function. This would be really, really useful. Another thing that you could do is you could also make idiomatic suggestions, right? Maybe you could read the code and you could find someone who is using a for loop over an array, and they're using a for loop to iterate over the elements of an array. Maybe what you could do is suggest that they use underscore, if that's like more stylistically what you guys like to do in your project. And so you could actually parse code, and you could actually suggest new idioms that are actually more appropriate for your team's code base. So these are just a few ideas. I wanted to talk a little bit about ideas for how you teach folks and how you might teach people to do programming. But you know what? I think we're actually running short on time, and I definitely want to take some questions. So I'm actually just going to open it up for that. If you guys would like to, to hear or to read kind of that last section, just send me a message on Twitter. I've got like a private Evernote. I'll send you the link. But yeah, I'd like to turn it back to you guys. If you have any questions, I'd love to answer them.
Great. Thank you so much, Nate. Okay, we do have several questions that have come in, and I know you've got your eye on the group chat. So the ones that we don't get to, maybe you'll have a moment to answer those, but we'll take a few
Absolutely.
here. Alper would like to know, can you use Esprima debugging /logging?
So Esprima, you could in one sense. Like Esprima generally is used to like parse your code into an AST, like into an object. And so what you could actually do is you could parse your code and then you could instrument it to automatically add tracing to code that you can detect needs to be traced. In fact, that's exactly what we do with Chalk, is that we parse your code and then we add invisible functions to it. So yeah, you could use Esprima for debugging logging, but only in the sense that like you have to then modify the syntax tree and then like add in your own tracing that way. Like you generate a new syntax tree that adds in your logging, you generate new code and then evaluate that code.
Great. We'll take our final question from John. What is the back-end versus front-end part of the Esprima parser? Can you explain these idioms?
I actually don't know the difference. Can we have another question so I don't have to end with that?
Sure. We'll take Garth's. Okay, folks, this is our final question for today's event. Garth would like to know thoughts on integrating this with IDEs a la Lighttable.
Yeah, absolutely. I mean, I don't know. I haven't used Lighttable extensively. I mean, I love Clojure and the work Chris Granger is doing, but in general, the idea, right, is that Esprima actually does really good at parsing code that's maybe incomplete or even has errors in it. And so you can actually look on their website. They have integrations with CodeMirror. That's actually what we're using for Chalk, where you could actually do like web-based IDEs that parses the code and it uses it for syntax highlighting is one of the easiest things, but you can also use it for refactoring, right? I think the refactoring use case is super interesting, that you can actually semantically understand the code that maybe like when you do a search and replace, right? That's really dumb, where you might have two variables in two totally different places, but they have the same name, and a search and replace might like break that. Whereas if you use Esprima, you can kind of validate the scoping, and then you can actually have a refactoring tool that refactors in an intelligent way. So I would, if you guys would like help with that or you're interested in working on that, just give me a shout out. I'd be glad to give you some guidance. So, all right, thank you very much.
Perfect. Thank you so much. And folks, we're going to turn the program for closing comments back over to Peter and Simon.
Great. Thank you very much, Yasmina. I just want to remind people that the full live version of Fluent will be in San Francisco, March 11th to 13th, 2014. You can find out a lot more at fluentconf.com. The best price for it ends pretty soon. It ends December 19th. And there's also an extra 20% discount code you can get for using Webcast, so I hope you'll check that out. I guess we'll close here with Peter.
Yeah, we have some really good people there as well that are going to be speaking, and if you don't get along to the event for whatever reason, I believe that we do live cast the keynotes, obviously not the entire show, but we do live cast the keynotes. So on the first kind of main day of the program, which is March the 12th, you will be able to see Brendan Ike, Pamela Fox, Scott Hanselman, Leah Veru, Ilya Grigoric, and then even more people on the last day of the conference. So there's always something to enjoy. So make sure you do follow us on the FluentConf Twitter account, because all this sort of stuff will go up there as well. So whether you do or don't make it to the conference, thank you very much for making it here today. It's been a real pleasure, and we've had some interesting talks. And we do hope to get to see some of you at the event as well. So feel free to come up and hassle Simon and I and say hi. So I think that's it for us. I just wanted to say thank you to all of the speakers as well for doing a great job. And thank you all for attending.